Imagine the simplest possible neural network. It's a basic structure, yet it holds the key to understanding more complex systems. It has just one layer, a straightforward and elegant design. And in that layer it has one single neuron, the fundamental building block of neural networks. This, my friend, is a single-layer neural network. It's the simplest form of a neural network, yet it can be quite powerful. And don't let its simplicity fool you. It can solve a surprising range of problems, from basic pattern recognition to simple decision-making tasks. In this essay, we'll focus on a specific type of single-layer neural network called a perceptron. The perceptron is a fundamental concept in the field of machine learning. The perceptron is a binary classifier, meaning it can sort data into two categories. This makes it incredibly useful for tasks that require a simple yes or no decision. Think of it like a decision maker that looks at various factors or inputs and spits out a yes or no as the output. It's like having a basic form of artificial intelligence. Each input to the perceptron is given a weight, signifying its importance. These weights are crucial as they determine how much influence each input has on the final decision. The perceptron sums up these weighted inputs and applies an activation function. This function is what allows the perceptron to make a decision based on the combined inputs. This function determines if the combined input crosses a threshold, ultimately deciding the output. If the threshold is crossed, the perceptron outputs a yes. Otherwise, it outputs a no. Let's create a simple dataset to illustrate how our perceptron works. This will help us visualize the decision boundary that our perceptron will learn. We'll generate 1,000 data points, each with two features. These features can be thought of as the x and y coordinates on a plane. Think of these as coordinates on a graph. Each point represents a unique combination of these two features. These points will belong to two distinct groups, forming two clusters in our dataset. This separation is crucial for training our perceptron. In this code, we first import the numpy library for numerical operations. Numpy is essential for handling large arrays and matrices of data. We then generate 1,000 random data points, x, with two features each. These points are randomly distributed across the plane. Our labels y are determined by a simple linear relationship between the two features, creating two distinct groups. This linear relationship helps in classifying the points effectively. Now, let's build our perceptron using TensorFlow and Keras. Here, we import TensorFlow and Keras and define our model. The keras.Sequential model represents a sequence of layers. Our perceptron has a single dense layer with one neuron. We use the sigmoid activation function, which squashes the output between 0 and 1, perfect for binary classification. Section 4. Training and evaluating our model. With our model defined, we need to compile it, specifying the optimizer and loss function. This step is crucial as it sets the stage for how the model will learn and improve. We use the Atom optimizer, a popular choice for its efficiency and adaptability in various scenarios. The binary cross-entropy loss function is particularly suitable for binary classification tasks, ensuring accurate predictions. During training, we feed our data, x and y, to the model for 20 epochs, updating the model's weights in batches of 32 samples to minimize the loss. This iterative process helps the model to learn from the data effectively. After training, we can evaluate the model's performance using various metrics and make predictions based on new data, ensuring the model's reliability and accuracy. Section 5. Conclusion: the power of simplicity. We've explored the fundamentals of single-layer neural networks through the lens of a perceptron. Despite their simplicity, single-layer models like the perceptron can be surprisingly powerful for linearly separable data. They serve as building blocks for more complex neural networks and highlight the elegance of learning from data. As you delve deeper into the world of deep learning, remember the power of simplicity and the importance of understanding the fundamentals.